Salut. Bon, on continue l'aventure de Dev 365 et on continue l'aventure de CS50. Bon, ici, on devait déposer le problème de Scratch, mais bon, le problème est déjà finalisé. Ce qu'il manque à faire, c'est juste lire les instructions et voir comment je vais déposer. Donc, je pourrais faire ça le week-end, vu que c'est pas si j'aurai assez de temps pour regarder tout ça, finaliser le projet et tout ça. Donc, le week-end, si je vais le faire le déposer et je vais faire une mise à jour. S'il faut faire une vidéo, le week-end, on va le faire. Donc, c'est ça. Mais on a déjà finalisé un peu de tout, comme ça s'est passé hier. Donc, je sais pas s'il y avait d'autres fonctionnalités qu'on devait ajouter. Donc, aujourd'hui, on va continuer avec la semaine lecture 1 qui fait partie de la semaine et ça serait l'apprentissage du langage C. Donc, ça c'est un peu plus ou moins ça. Donc, ça serait parti. Et aussi, il y a un moment donné, parfois je vais arrêter le son de le PC parce que j'ai eu des problèmes de copyright. Donc, il y a des musiques qui sont passées sur le coup que, bon, j'ai pas le droit de poster ça. J'ai pas le droit de poster cette musique. Donc, ça m'a fallu un peu plus de temps pour retirer la musique et poster. Donc, c'était plus ou moins ça. Donc, c'est ça. Donc, là maintenant, c'est l'introduction. C'est parti.
Is CS50, and this is week 1, our second week together. And you'll recall that last week, week 0, we focused on Scratch ultimately, this graphical programming language via which you can drag and drop puzzle pieces that interlock together, only if it makes logical sense to do so. And many of you had actually probably played with that in like middle school or even prior at some point. But for our purposes, the goals of Scratch were to give us sort of a mental model for some fundamental constructs that we're going to see again and again today in C, in a few weeks in Python, and even thereafter. And those include things like functions and return variables and arguments and variables and loops and conditionals and more. And so even if today feels like a bit of a fire hose, such as that pictured here, appreciate that a lot of today's ideas are exactly the same as last week's ideas. It's just that the syntax is going to change. It's going to look a little different. It's going to look a little scarier. It's going to be harder to sort of memorize, except with practice will come that muscle memory. But the ideas ultimately are going to be the same. And indeed, this is, if unfamiliar, MIT down the road has a tradition of hacks whereby students once a year do something fairly crazy. And at this point, they happen to connect an actual working drinking fountain to an actual fire hydrant. And the sign there, very pixelated, says, getting an education from MIT is like trying to drink from a fire hose. And that's indeed how computer science, how programming, how CS50 will sometimes feel. But realize that what's going to be ultimately most important is not where you feel you are day after day, but where 3 months from now you feel that you are relative to last week alone, so-called week 0. So let's look back at what week 0 looked like. It looked a little something like this, the simplest of programs via which we get that cat to say, hello world. Today, that same code is going to start to look a little like this, which was a glimpse we gave you last week. But this time I've deliberately color-coded it to try to send the message that whereas in Scratch we had this yellowish puzzle piece that sort of kicked things off, that didn't really do anything itself, but it got the program started, whereas the real work was done in purple here. Same is going to be true today, whereby I'm going to wave my hands for a little bit of time at this yellowish code on the screen, but what's really going to have the most effect is this same purple line here and the white text within. And we'll break down what all of these lines mean over the next couple of weeks, but sometimes we'll wave our hand at details if we feel it's a little unnecessary at this point in the story. And in fact, let me get rid of the color coding for now, and we'll see that this is the kind of code in a language called C we're going to start playing with and using today and for the next several weeks. And indeed, it's representative of what we're going to generally call source code. So source code is what programmers write. It's what you write. It's what you wrote, albeit by dragging and dropping puzzle pieces. This week onward, you're going to start using your keyboard all the more, and you're going to write source code. So this is code that we humans can understand with some training and with some practice. But of course, per last week, what language do computers ultimately understand? Only So binary, zeros and ones. And so you and I, yes, can write code starting today in a form that looks a little something like this, which admittedly might look a little arcane and cryptic, but it's certainly better than a whole bunch of zeros and ones. But we're going to write in source code, but the machines that we write code for ultimately only understand these here zeros and ones, which may very well say hello world, but we're going to call this moving forward machine code. So machine code is what the computers understand, only the zeros and ones. Source code is what you and I understand and actually write. So it stands to reason that we're going to have to somehow translate one to the other, from source code to machine code. And I alluded to this ever so briefly last week, but we're going to use this same mental model whereby the source code we write might be the input to some problem. The output we want therefrom is going to be the machine code. So what we're going to equip you with today inside of this proverbial black box is a special piece of software that takes source code as input, produces machine code as output, and that type of program is called a compiler. And there's bunches of different compilers in the world. We're going to have you use one of the most popular ones, but it's simply a piece of software that someone else wrote that converts one language to another. Source code, for instance, in a language called C, to machine code, the zeros and ones that our Macs, PCs, phones, and other devices actually understand. So where are we going to do this, and how are we going to do this? So I promised last week that we'd introduce you to this here tool, which I used briefly at the very start of class to whip up that chatbot. We're going to use it, though, not for Python this week, but indeed for a different language, C. And indeed, this tool, Visual Studio Code, or VS Code for short, is super popular in industry. This is what real programmers, so to speak, are using all of the time nowadays. There's absolutely alternatives. If some of you have programmed before, you might have used or experienced different tools, but this is a very common tool that you'll see even after CS50. And in fact, it's something that ultimately you can install for free on your own Macs and PCs so that by the end of the course, you're completely independent of CS50 and any CS50 related tools. But what we have done for the very start of the class is essentially provided you with a cloud-based version of this tool. So all you need is a web browser on any Mac or PC or the like, so that everything's pre-installed for you, pre-configured for you, and you don't have to deal with the stupid technical support headaches at the start of the term, because it should just work. But by the end of the term, once you're a little more comfortable with technology and with code in particular, you can absolutely offboard yourself from this tool, install it, download it on your own Mac and PC, and have pretty much the exact same environment completely under your control. So starting today, you're going to see an interface that looks quite like this quite often. And we used this same interface last week ever so briefly. Moving forward, here's where we're going to write code. At top right is where one or more code tabs are going to appear, similar to any tabbed environment that you might use. Here, for instance, is just a screenshot of the first file we'll create today called hello.c. The reason it's called hello.c is because it's in a language called C, as we soon shall see. No pun intended. Meanwhile, the code here happens to be color-coded, not quite in the same way as you saw before, because I manually made it look more like Scratch blocks. But among the features that VS Code and other programming environments provide is something called syntax highlighting, whereby you don't worry about or even think about these colors, but as you write out code in a recognized language, tools like VS Code will just color code different parts of your code for you, just to make different features jump out. And we'll see what those features are over the course of today. But you'll also spend a good amount of time, as I briefly did last week, down here in the bottom right of your screen, the so-called terminal window, which is going to be where you run commands for compiling code and writing code. And in fact, as we'll see today, you're going to start using your mouse and clicking a little bit less. You're going to start using your keyboard and typing a bit more.
Ah, mais c'est un Python. Bizarre.
And ultimately, even though if at first that might feel like a step backwards to sort of not use something that's so user-friendly, the reality is most every programmer tends to find themselves ultimately much more productive, much more powerful using the keyboard more often, more quickly than, say, a traditional mouse or trackpad would allow. Meanwhile, we'll see some somewhat familiar features here at left, like this is where you'll see the files and folders that we'll create over time. At far left here is going to be an activity bar, which is essentially a modern form of a menu via which you can open and close things and access other features. For my purposes, I'll generally hide this part here. I'll generally hide this part here so that when we're together, we're focusing almost entirely on code and commands. But I'm just typing some quick keyboard shortcuts to simplify my own user interface in that way. So, with all that said, just some terminology. So this whole collective environment that I'm describing here is generally what's known as a graphical user interface. Why? Well, it's an interface for users that's graphical in nature, with icons and buttons and the like. Shorthand notation for this is GUI, G-U-I for short. But within this graphical user interface, as promised, is going to be that terminal window at bottom right, where I promised we would be typing most of our commands. And just to give you a bit more jargon in computing, that's generally known as a command line interface, or CLI for short, whereby you're typing commands into that interface instead. And the world of computing software is essentially divided into GUIs and CLIs, and sometimes a piece of software might have one of each as well. But without further ado, why don't we go ahead and focus entirely first on this here program, which I dare say is the simplest program you can write in a language like C, and see how we can actually compile and run it together. So I'm going to go over to VS Code here, where I've hidden my file explorer with all the icons, and I've hidden my activity bar so that only do I have room for tabs of code and the command prompt at the bottom. I'm calling this a command prompt because it's at this $sign where I'm going to run some of my commands. And it's a $sign by convention. It has nothing to do with currency. It's just a computing convention. Some systems will use a caret symbol. Some systems will use a greater than symbol, rather, or something else. But it just means type your commands here. The first such command I'm going to type is this: code hello.c with a single space in between. I've not used any spaces in the name of the file. I've not capitalized any aspect of the file, just because this is convention, unlike your Mac or PC, where you might be in the habit of naming files with spaces and capitalization. Generally, you'll make your life simpler by just using lowercase and no spaces at all. As soon as I hit enter, what you'll see is that a brand new tab appears called hello.c with a cursor blinking on line 1. And this is essentially VS Code waiting for me now to type the first line of my code. Notice, though, that the command is complete, whereby I have another cursor here, which if I click in the terminal window and give foreground to it, my cursor might blink there instead. That just means I can type another command when I am ready. So let's go ahead and whip up this code. And I've done this many times, so I can type it fairly quickly. But in this tab, I'm going to do include standard io.h, so to speak, int main void. Then inside of so-called curly braces, indenting therein by 4 spaces, I'm going to say printf, quote unquote, hello, comma, world, \n, close quote, semicolon. And voila, I've written my first program in C. In a class like this, no need to write down each and every line of code that I write. In fact, on the course's website will be copies of everything that we've done, as well as excerpts therefrom in the course's notes. But you're welcome, but not expected, to follow along in real time with what I am typing here. So that's it. Like, I've written my very first program in C. If I had done this on an actual Mac or PC without a command line interface, I might have a new icon on my desktop, so to speak, called hello. And ideally, I could double click on that or tap on it and run the program. But because I'm in this specific programming environment that has a mix of a GUI and a CLI, I actually need to click down in my terminal window, and I need to now compile this program first, because at this point in time, it exists only as source code. So to do this, I'm going to compile my code by very aptly saying make space hello. And I'm pronouncing the space, but literally I hit the space bar. Make space hello, as it sort of implies semantically, will make a program called hello. Notice I have not said hello.c again, because the compiler, let's call it make for now, even though that's a bit of a white lie, is going to infer that if I want to make a program called hello, it's going to automatically look for a file called hello.c in this case. So a bit of magic. Enter. And remarkably, anytime you don't see any output at a command like this, that's probably a good thing. Generally speaking, when you see output when compiling your code, you have done something wrong, or in this case, I might have done something wrong. But no output is good, because what I can now do, and this is a bit cryptic, I can run this program not by double-clicking or tapping anywhere, but by doing /hello with no spaces. And this is a bit weird, but what the // means is that having just made a program called hello, that program's going to end up in my current folder. It's somewhere in the cloud, yes, more on that in a bit, but the program called hello is just somewhere in my current folder. When I say /, that's like saying go into the current folder and run the program therein called hello specifically. Now, as I'll often do, I'll cross my fingers, hope that I didn't mess this up in any way, and I should see in a second hello world indeed printed onto the screen.
Okay.
And so just to recap those then commands, one, I ran code hello.c, which is a VS Code specific thing. Code, short for VS Code, just creates a new file called hello.c, and then I'm on my way with my own keyboard. Make hello compiles that source code into machine code, thereby creating a new file called hello.
Mais
And
pourquoi
to
on peut
run
pas
that program
regarder?
hello, I type this strange command /hello. But this is a paradigm. No matter what you call your programs, we're going to see again and again and again. So even if you've not done something quite like this, it will very quickly get familiar.
Ah, c'est juste la syntaxe
Yes,
qui est quand même
questions?
vite. Et c'est...
When you say make hello, how does the computer know what part of the code to run? What part of the code is ascribed to hello?
Good question. When I say make hello, how does the computer know what part of the code is ascribed to this program hello? It literally is going to take the entire contents of hello.c and turn them somehow into a program.
And does it have to be named hello or can it be anything?
Does it have to be named hello? No, I could have called it goodbye or anything more, my first program.c, anything at all, so long as I change these words here accordingly.
But it needs to be from the same thing.
Yes,
When I have green.c, then it make green or whatever.
exactly. If you change the name there, you need to change your commands accordingly. Other questions on these here steps? No? All right. So let's tease apart what it is we just did and why this code works in the way that it does. Well, to recap, in Scratch, we had a program like this. When the green flag was clicked, we wanted to say hello world onto the screen. The code that corresponds to that is roughly here. And indeed, notice that the yellowish or orangish code lines up with the when green flag clicked. The purple code here lines up with the say block. And the white code inside of here roughly corresponds to what was in the white oval that we kept using again and again last week. So let's do more of a one-to-one correspondence. And these slides are deliberately designed to give you, again, that sort of mental model of taking same ideas from last week and just changing the syntax this week onward. So when we have a function like this thing here, and recall that a function is just an action or verb, it sort of accomplishes a small piece of work. In code, in C specifically, you're going to type, of course, not a purple puzzle piece, but you're going to say the word print. Well, more technically, printf, where the F, as we'll soon see, means format the printed output, because this is more powerful than just printing some raw text alone. Then you can have parentheses, open and close, left and right. And notice that it's no accident that MIT chose an oval for their input to functions, because it roughly looks like the start of a parenthesis and parenthesis on left and right. Meanwhile, what goes inside of the parentheses in the corresponding C code, well, at the end of the day, minimally, hello, comma, world, because that's literally what we want to print to the screen. But in C, unlike in Scratch, there's a bit of overhead, a bit of additional syntax that you just got to deal with to make clear to the computer what you want to print. In particular, you're going to have to surround everything you want to print with double quotes to make clear that hello is not some special function or variable or something else. It's hello world is the English phrase that you want to print. So double quote here, double quote there means here's the beginning and the end of what I want to print. You're also curiously going to put a \n in most cases at the end of the word or words you want to print. We'll take that away in a moment and see what it does. And then lastly, and perhaps most annoyingly in programming circles, you have to finish your thought with a semicolon. Much like in English, you would finish most sentences with a period instead. And the thing about programming is, with C in particular, if you mess up almost any of these details I just rattled off, something's going to go wrong. And so you're in good company. The very first program you try to write or try to compile, odds are it might not work correctly, because you'll develop over time the muscle memory for spotting all of these seemingly minor and actually minor details, but that do matter to the computer. All right, so if you're familiar, of course, with the notation in mathematics of functions, a function in code is really the same idea as a function in math, whereby the function f takes some input, for instance, x, and generally produces some output. So if you're coming more from that background, realize that what we're really doing here is roughly the same. But in code, recall that we can have different types of output. So if this is our grand mental model, and say we've got a function as inside of this black box that takes arguments, that is to say as its inputs, it can sometimes have side effects. And recall that side effects are often visual things that happen as a result. They just display on the screen, maybe it comes out of the speaker. It's something generally ephemeral that just happens. But it's not necessarily useful in the same way as another type of function that we'll return to in just a bit. But last week, recall that we got the cat with a speech bubble to manifest on the screen and say, hello world in that speech bubble when the input was hello world and the corresponding function was instead say. So let's see if we can't now tease apart what the code we wrote is actually doing for us bit by bit. So let me go back to VS Code here, and let me propose to break this in a little way. Let me delete the \n, if only because at first glance, who knows or cares what that's doing. Let's just get rid of it if we don't understand it. I could now go back down to my terminal window, and I could do /hello, enter again, but there's seemingly no change, which is good. It doesn't seem like I broke it. But I've kind of misled you here. Why? Why did nothing seem to change? I didn't recompile it. So recall that the compiler converts source code to machine code. But I already did that a couple of minutes ago. If I've changed the source code, it stands to reason that I need to recompile the code to actually see the effects of that. So let me do that again. Make hello, enter. Nothing seems to have gone wrong. But let me now do /hello, enter. And it's subtle now, and in fact, let me go ahead and zoom in. It's really just an aesthetic bug insofar as functionally the program is still technically printing hello world, but what's seemingly wrong? Or put another way, what did the \n apparently do? Yeah. Yeah, so it's somehow giving me a new line, and that's essentially what the \n denotes, is give me a new line there. And why was I doing that? Well, really just for the aesthetics. Like if this $sign represents my prompt where I type commands, if anything, it just looks kind of stupid that I finished a program over here, and then the prompt is on the same line. It just looks wrong, even though you could sort of argue that was my intent, even though in this case it wasn't. So what would the alternative be? Well, what you're seeing here is what's actually generally known as an escape sequence, which are sort of special sequences of symbols, like \n in this case, that do a little something unusual. And here's just a non-exhaustive list of some you'll encounter in the real world, and including in CS50. \n moves you to a new line. \r is a so-called carriage return. If you've ever seen or used an old school typewriter, this refers to the process of bringing the typing head back to the left end. So it sort of moves the cursor horizontally as opposed to vertically. This one's interesting, \. Why does there exist this pattern, \. Yeah. Exactly. So recall that phrase we tried to print out, like hello, world. If for some reason you didn't want to say hello world, but you wanted to say or like sort of snarkily, like hello world or something like that, well, you can't put a quote, a quote, a quote, and a quote and expect the computer to know which quote corresponds to what. It's just arguably ambiguous. So if inside of double quotes, you actually want to print actual double quotes, this is a escape sequence that tells the computer this is not some quote delineating where my thought begins and ends. This is literally a double quote. And we'll see other situations in which a single quote or apostrophe is the same. We'll see crazy situations in which you want to print a \, but \/ already has some special meaning. So there's solutions to all of these problems. But let's not get too far into the weeds here. But let me go back to the code and propose what the alternative otherwise might have been. If I didn't know about \n, my instinct to move the cursor to the next line might have been literally to just like hit enter or do something like this, like move the double quote, move the parenthesis, move the semicolon onto the next line. But this should start to rub you the wrong way, and indeed this violates a principle of most programming languages, in that most programming languages are line-based. You sort of start and finish your thought ideally on the same line. And this runs afoul of that. And two, even if you're seeing code for the first time, assume that this just looks stupid as well, to sort of move part of your thought to the next line. It just looks a little sloppy, and it is. So C and many other languages, Python among them, solve this by giving you these so-called escape sequences. So if you want a new line there, you do \n, and you will get your new line there. Now that's a bit of an overstatement what I said, in that sometimes lines of code will be so long that they do wrap onto multiple lines, but generally that's a convention that we're going to try to avoid. All right, what else could go wrong? Well, let's do this. Let me go ahead and clear my terminal window, which I can do by hitting Control L, or I can literally type clear. And I'm going to frequently do this just to keep the screen clear, even though it has no functional impact. It's just an aesthetic. Let me do something else accidentally. Suppose I forgot to finish my thought, and I omitted the semicolon, but otherwise the code is perfect. Let me do make hello now. Enter. Now we're going to see some output that's a little more arcane. Let me go ahead and scroll back up here to make clear that what's just happened is I ran make hello, but I didn't get back to another prompt. I don't see immediately a $sign because there's an error message here that is almost as long as the code I tried to write. Not to worry, let's see. Here is the name of the file in which the problem exists. Stands to reason that it's in hello.c. Here is the line number in which the problem seems to exist, line 5. And that's helpful because it lines up with this. And then if you care to count, this is the 29th character. So if I count from left to right, around character 29, something is wrong, something is missing. So it's a pretty decent error message. In fact, it even says expected semicolon after expression. There's a little green caret symbol pointing me at the mistake. So this is, again, this is another value of the compiler. Not only does it know how to convert source code to machine code, it's also pretty good at finding mistakes in your code and trying to draw your attention to them. So how do I fix this? Well, assuming you've understood the error message at this point, well, you just go back in, add the semicolon. Let me go back down to my terminal window. I'm going to clear it just to clean up the mess. Let me rerun make hello, and now we are back in business. And indeed, if I do /hello, I've got hello world back on the screen. Well, let's make one other mistake. Suppose that I forgot, as you sometimes will, to include this line at the top, which will make more sense next week. But for now, let's just omit it and dive right into the code. You would think this is enough, just printing out hello world. Well, here, let me go back down to my terminal window. Let me do make hello again now, and I'm going to get a whole different error message instead. So now, problem is still with hello.c. That makes sense. Line 3. OK, so somewhere in there, printf is suddenly the problem, even though the semicolon is back and the \n is back. So let's keep reading. Error, call to undeclared library function printf with type int. And then this is a whole mouthful. So here's an example of an error message that, unless you're sort of conditioned to know what this means, and you've seen it before, it's quite more cryptic and unclear like what the solution to the problem is, especially when the rest of your code is truly correct. I've just forgotten something stupid. But how can I sort of think about this problem? Well, it turns out that another feature of C is that it comes with a bunch of header files. A bunch of files whose names don't end in .c, but end in .h. And these so-called header files, which end in .h, contain code that other people wrote that you can use in your own programs. So for instance, in this particular case, a header file is giving us access to what's more generally in computing called a library. A library is code someone else wrote that you can use. And I actually used a library last week. When I did that import line and mentioned OpenAI, the company, I was actually using a library from that company that I had automatically downloaded and installed into my programming environment in advance of class, because I don't know how to implement a chatbot without standing on their shoulders and using a lot of the code they themselves wrote. Same idea here. Even though printf is a feature of C, if you want to use it, you have to include that library by telling your program to include the header file that defines that function. And you only know this by being taught it or looking it up in a book or a reference. But in this case, I wanted to use a header file called standardio.h, stdio.h. It is not studio.h. This is a very common bug online. If you find yourself typing studio.h, typo, it's standardio.h. And in that file, then, is defined the printf function. So if I go back to my code here, the solution to this problem truly is to just undo the deletion I made a moment ago, because what line 1 is now doing for me is it's telling the compiler, oh, by the way, I didn't write all of the code that I'm about to use. Please include the definition of printf from this other file called standardio.h. And again, you'd only know this by looking it up in a reference, attending a lecture, or something like that. It's not obvious otherwise. But these are the kinds of things you very quickly look up. So where do you look them up? Well, it turns out the ecosystem of C has hundreds of books you can buy or download, many, many, many websites. Among them is one of CS50's own. And in fact, the conventional way to look stuff up for the programming language called C is to look at the official manual pages, or man pages for short, for the C language. Unfortunately, many of them were written decades ago, and they were certainly written by fairly advanced programmers and not for a broad audience. And so what we have done is imported all of that freely available documentation, hosted it at our own URL here, manual.cs50.io, and we've essentially simplified it for those less comfortable, those of you who might be less familiar with, less comfortable with technology, and really for most people who aren't used to reading manual pages, it's just useful to have it written in teaching assistant-like language instead. So for instance, if you go to a URL like this, you'll see CS50's documentation for this official library, standard.io.h, that comes with C itself. If you go to a URL like this, you can look up the documentation for printf itself specifically. So for instance, let me go ahead and just give you a teaser for this. If I were to do the same on my own computer, I might see the CS50 manual pages here, and you'll see header file by header file, a bunch of frequently used functions in CS50. We've also filtered the list down from a massive list to a much shorter list so that you can sort of see what's most likely useful to you. If you go to a specific page like standard.io.h, you'll see, for instance, here just over a half dozen functions that we won't touch on today beyond printf, but that we'll see in the class over time that does useful stuff. For instance, printf prints to the screen, and we'll see other functions for opening files, closing files, and the like, because all of that's related to standard I/O, input and output. If I go to a specific man page for this header file, you'll see the standard formatting for these pages. So here's the name of the function, printf, and it prints to the screen. You'll see a synopsis, and this indeed indicates we're in less comfortable mode. If you want to see the original, more arcane documentation, just uncheck that, and you'll see the original official documentation. But you'll see a mention of like what header file this function is defined in, so that you know what file to use in your own code. You'll see a so-called prototype, which is just the first line of code from that function. More on that in just a little bit. You'll see an English description. You'll see example code. Long story short, this is the authoritative answer. And even though you have access in this class to the virtual rubber duck at cs50.ai and other forms of it that you'll soon see, you should also have the tendency and the instinct moving forward to check the official documentation. And all of today's AIs are trained on things like the official documentation, so that's the source material that any of these AI, the duck among them, are actually relying on. But what we're also going to see is that besides these official functions, there's some that CS50 itself has invented. We use these really as training wheels for just the first few weeks of the course, and then we take these training wheels off. But the reality is, in a language like C, certain stuff is just really hard or annoying to do. Certainly if you're learning how to program for the very first time, or at least you are new to C. We'll eventually show you how to do it that way, but even if you just want to get input from the user, like a string of text or a number of some sort, it's generally not that easy to do in C, at least in these early days. So for instance, at this URL here, you can see documentation for CS50's own library and CS50's own header file, cs50.h, and you'll see such functions in the documentation as these: get string, get int, get char, and a bunch of others as well. And we'll touch on those this week. But it will ultimately be a way of just getting useful work done quickly by standing on our shoulders and actually using functions we wrote to then solve problems of interest to you. So let's focus, for instance, on one of these first. Get string. A string in programming speak means text, 0 or more characters of text, like HELLO, comma, space, WORLD. That is a string of text in computer speak, and it's obviously not a number like 50. It's actual text that you would type on the keyboard. We'll see then what other things we want to get, but with this function, we can start to replicate another program that we implemented pretty quickly last week in Scratch. So recall that in Scratch, this one was a little more interactive. I used another blue puzzle piece, ask, to actually get input from the user. And recall that unlike the printf function today and the say block last week, this time we still have the same input-output model, but if we pass in arguments to a function that we're about to see, you can get back not just a side effect sometimes, but a return value, like a useful, reusable value, like the person's name, as we'll soon see. All right, so let's actually do this. If in Scratch, the equivalent was asking the user, what's your name? Asking them that, and then waiting for an answer that we can store in a variable, let me propose that in C, side by side, it's going to look a little something like this instead. At left, we have the Scratch block, the ask function. Here is the argument there, too, and then and wait just means it's going to wait till the user finishes typing. If I want to translate this to C now, today moving forward, well, it looks a little something like this. The closest analog in C, thanks to CS50's library, is going to be a function called getString. So there's no C function called ask, and we deliberately name this function getString just to make super clear what it is you are getting, a string of text in this case. And we've got the parentheses ready to go, indicative of this white oval for user input. If I want to prompt the user with that same phrase, what's your name? Well, I can just put it inside of those parentheses. But what next do I need to add around my user input? Yeah, I need the quotation marks just to make clear that these aren't special individual words. This is a whole phrase that I want to be displayed to the user. So I'm going to indeed put double quotes around everything. And this is just an aesthetic. I don't, in this case, want to bother moving the cursor to the next line. Like, I want the user to see the question, and I want the cursor to just stay there blinking, waiting for their prompt. But I don't want the cursor to be right next to the question mark. So I'm deliberately just leaving a single white space there just to kind of scooch it over a bit so it looks a little prettier, at least to my eye. Now, we're not done yet, because we need to do something with this value. The getString function, as we'll soon see, is going to prompt the user for me to type something in, like my name. But where do I want to put that? Well, MIT has the answer put in a variable called answer. And you can't rename that in Scratch. It's just defined as answer. But in C, what I'm going to need to do is something like this. If you want to keep return values around from a function, you literally use an equal sign. And then to the left of it, you put the name of the variable into which you want to put that return value. So in mathematics, we would use x, y, and z as our variables. Again, in code, as in Scratch, you can name your variables anything you want. By convention, they should usually be lowercase. They should not have spaces therein, similar to file names. But this is a pretty good analog now of what's going on collectively here. But C is a little more precise. You can't just give the variable a name. You need to tell C, or really the compiler, what type of value you want to put in this variable. So if it's a string of text, you put string. If it's a number, you're going to put something else. But for now, it's a string. Per the function's name, it's going to give me a string. Now, we're so close to finishing this comparison. There's one detail missing. What's still missing from the code here? Yeah, so we have to finish the thought, lastly, with a semicolon. So if you're getting the sort of the point already, like, this is one of the reasons why we start with Scratch. You get the intuition pretty quickly. And even though nothing on the right-hand side is particularly hard, there's just all these stupid little details that you have to ingrain in yourself over time. In this case for C, but for many programming languages, we're going to see the similar paradigm. But among the goals of the course, too, are to show you how ultimately languages have been evolving. And so one of the things we'll see in Python in a few weeks' time, that some of this syntax actually goes away. Because over time, humans have gotten annoyed at older languages like this. Like, why the heck do I have to keep putting a semicolon when it's clear that I'm at the end of the line? So we'll see, among languages like Python, we can get rid of some of these same features. But for now, it's just a matter of remembering what goes where. All right, so let's go ahead now and take that same idea of converting Scratch to C and actually do something with this code. Let me go back to VS Code here. I'm going to keep my file name the same, but what you'll see on CS50's website is that we'll add version numbers to each of the examples that I'm typing out, so you can actually see the progression of these programs, even though we're not changing the name. And what I'm going to go ahead and do here, for instance, in hello.c this time, is the following. I'm going to go ahead and first get rid of the single hello world. I'm going to go up here and include, this time, cs50.h, so not one but two header files. And then inside of my curly braces, inside this so-called main function, as we'll soon call it, I'm going to go ahead and do this. Exactly the same line of code as on the screen before. I'm going to get a string prompting the user for what's your name, question mark, space, close quote, semicolon. And as an aside, this we'll soon see print on the screen. What's your name? So that implies that the getString function is actually using printf itself to print out that message. I do not need to use printf to display that message on the screen because I read the documentation for CS50's getString function, and I just know that it is using printf for me to achieve that particular goal. Now let me do something intuitive but not quite correct. If I want to print out that answer so that the expression is going to be not hello world, but hello David or hello Kelly, let me go ahead and say hello, comma, answer, \n to move the cursor down as before, semicolon. So this is not quite right, and even if you've never programmed before, you can perhaps see where this is erroneously going. Let me remake the program, because I've changed the source code and I need new machine code. Nothing seems to be wrong syntactically, But if I do now /hello and hit enter, you'll see I'm being prompted. What's your name? So I'm going to go ahead and type in David and then hit enter. But when I do, if you know where this is going, what am I going to see instead? Hello answer. And the computer's just doing literally what I told it to do. I said, quote unquote, print out hello answer, but obviously that's not the goal that I have in mind. So how do I actually work around that? Well, what I really need to do is achieve the equivalent of this thing here, which we did by stacking blocks in Scratch, or nesting them, if you will, one inside of the other. So I want to join the expression hello, comma, space, and that answer. And it turns out in C, you can't do it quite like this. Like there isn't an analog of the join function, at least that we'll see today. So we have to do this a little bit differently. We can do it, though, by maybe telling the computer, well, go ahead and print out hello, comma, space, and then maybe we can give it like a placeholder to plug in the name once we know the name. Because when I'm writing my code, I have no idea who's going to play this game, me or Kelly or someone else. So what if we use special syntax to indicate where I want the person's name actually to go? Let me propose that we now do this. Instead of printing out hello, quote unquote, hello, comma, answer, quote unquote, let's go ahead and start printing out something. And I got my parentheses ready to go, and I did my semicolon in advance this time. I want to somehow now say hello, comma, placeholder. And you would only know this by someone having told you or a reference online. Percent %s is the placeholder for a string that you don't know when you're writing the code, but when someone else is running the code, it will be filled in and substituted for their input. So hello, comma, %s is the closest we can get to this. I still need, though, some other syntax. I do need those quotes on the left and the right. Just to be aesthetically pleasing, I'm going to put a \n there at the end to move the cursor. But now I've left room in my parentheses for one more thing. And you could perhaps guess where I'm going with this. Again, even if you've never programmed before, this is telling printf, print out HELLO, comma, space, something. What should I probably pass in to these parentheses as a second input so that printf knows what that something is? Yeah. The variable name. So the variable in which I have the user's name. And indeed, the convention is to put a comma after the quotes and then the name of the variable that has the value you want to be substituted for that placeholder. Now notice there's a collision of syntax and grammar here. The comma inside of the quotes is just an English thing. Hello, comma, so-and-so. The comma outside of the quotes is meaningful to see because it delineates which is the first input or argument to left and which now is the second. And we haven't seen this before in C. Up until now, we've only been passing one input, but you can pass in 2 or 3 or 4. Completely depends on what the function is
Je
designed
pense que ce serait tout
to
pour la
expect.
vidéo
So let me
d'aujourd'hui.
put this all together now. Let me go
Je suis un
back
peu
to
fatigué,
VS Code.
mais
Previously,
je
we
veux
were
continuer
literally
ça
printing out
offline.
answer, but I can change answer
On
to
va
%s.
peut-être
I
continuer
can move my cursor
demain,
outside of
ou
those quotes,
bien
comma, answer, because that's the name I gave to that
je fais le
variable. I can
programme.
go back down to my
Parce que je
terminal
pense
window
que
and
je vais
clear it, just to reduce clutter. Let me do make hello one more time. Seems to work. /hello,
Je suis
enter,
fatigué.
DAVID, and now hello, comma, David is printed.
Là, on sait tout, on s'est dit. À
Okay,
demain aussi, je finis pas ça
questions on any and all
offline.
of that?
Genre, je vais peut-être finir ça.
Good question. Where is it
Demain.
pulling these header files from? So what you are seeing
ça, c'est
here
plus ou moins
is
ça.
a graphical user interface